We're going to set up the dial caliper to measure the bore gauge or the bore diameter of the spark engine. I already looked up the bore diameter of the spark engine, and it is 70.5 millimeters, so 70.5 millimeters. We're going to set up the bore gauge, and then we'll go measure the bore diameter. Now the bore gauge, you've got several different adapters here, and they come in different increments. And we want to choose the bar that is just slightly over what our cylinder diameter is. And so to figure that out, there's a couple ways you can do it. You can do the math to convert the millimeters to inches, because these are all in inches here. Or let me show you something else. We can take our our digital caliper, and we can convert it with the digital caliper. So first of all, we're going to make sure it's zeroed. So we're at 0, and then we're going to set the caliper to 70.5 millimeters. So let's change it to millimeters, and it shows up right there, mm. And so we're going to run it out to 70.5. So let's see, go up to 70. Oops, 70.5. Oop, a little too far. And we're almost there. Right there, 70.5. We can lock that into place. So 70.5 millimeters, and then we can switch that over to inches, which gives us 2.775 inches. And so what we want to do now is we want to choose the adapter that is just a little over 7 or 2.7 inches. So we probably want to use this one here. No, that's not that one. 2.8 inches. Okay, so we're going to go with the 2.8 inches, and we'll go from there. We've got to put the dial on the tool itself. So we're going to slide the dial in there, and when I set up the dial, what I want to do is I want to get it in here so that we've compressed it a little bit so that needle moves. I like to go in at least 1.5 to 2 inches or 2 revolutions around. Then we tighten the set screw, and we got the dial on there. Now the way this thing works is back here on the back side of this little guy here, you got a little pin, and you're going to push that pin, and that pin actually makes the dial move. And so that's why you want to set your dial up so that it's just slightly over the bore diameter. Now I've already set my caliper to the correct diameter of the piston, or the cylinder diameter, and I've locked it into place so these jaws can't move. Now what I'm going to do, or what I've done, is I've clamped it into a vise, and when you clamp this into a vise, be careful that you don't damage the tool. So I've got a rag in here that holds it, and also when I tighten down the vise, I just tightened it just enough so this is solid and it doesn't move around. Now what we're going to do is we're going to put our adapter inside of the bore gauge, and so to do that, you just remove that little cap and install the adapter right here, and we're going to test it out and see if it's big enough. So the way you test it out is you set it right inside the diameter here, and if you look at the gauge, when I rock it back and forth, so I'm going to put that little button right here on the thing and rock it back and forth, and if you notice, it's not actually touching. If you look over here on this side, I'm a little bit shy, so this isn't actually moving. So what I need to do is I need to add a shim to it. So I've got to take this adapter out, and I've got to put a shim on here so that it will measure correctly. Now I do have a box of shims, and they're different thicknesses. So I can, there's this one here that's a really thick one, and then it goes all the way down to this one here, which is a really tiny one. And so what I want to do is I want to pick a shim so that it makes the adapter long enough that I can actually get a measurement. And I'll show you what I mean here in just a second. So I'm going to put that in there. Oh, and let me show you how I put the shim on there. You got it, the shim is right here, and you have to be very careful not to lose these shims. They are really small, they drop off, they are easily lost. Okay, so now I can put it in here and I can actually measure right there. So that I used the middle thickness shim, and it was I think it was a 5/1000 shim, 0.05. But anyway, this one works. So we'll go ahead and zero our caliper out now. Let me show you how that's done. Okay, once I've got my caliper in the bore gauge in the caliper, I can rock it back and forth like this. Whoops, if I get it, hold it in there right. So I can rock it back and forth like this, and you see where the gauge starts to change directions? I want to zero that out right about there. So right about there is where I want my zero. So if I rock this back and forth, that needle should never go past the 0 in the caliper. So I need to move it just a hair more. There we go. Right there, we're zeroed. Okay, so now I'm ready to go and measure the bore diameter. I already covered a lot of this in the textbook chapter, but this is a little more hands-on where we can actually see what's going on. There's three things we're measuring for when we do measure the bore. We're measuring for taper, we're measuring for out of round, and we're measuring for diameter. And so what we want to do is we want to measure for taper when, and I explained this when we went over the chapter, but over time it is possible for the cylinder to have a different thickness at the top, middle, and bottom based on wear. So a lot of times what it does is it gets thinner at the top than it does at the bottom. And so we need to measure up here, in this area up here. So we need to measure up here, we need to measure in the middle, and we need to measure down here. And that's what we're going to be measuring as far as taper goes. For out of round, now this is what do they call that? Kind of the business side of the piston. So as the piston's going up and down in the cylinder, it's going to have force placed on the piston, and it's going to be rocking it back and forth. And so if the engine is in this direction here, so if the engine is longitudinal like that, or transverse like this, whatever. So this is the front of the engine, this is the back of the engine. So the piston's going to sit like this in the cylinder block. As the piston's going up and down, every time it goes up and down and it's rotating on the crankshaft, that piston is going to be rocking back and forth. So there's going to be pressure that's exerted here and pressure that is exerted here, which could make the cylinder out of round. So this could wear a little bit more than this side, and so we need to measure that. We need to measure and see if it's the same distance here as the same distance here. And that's kind of what I've got drawn over here on this side. So just make sure you can see that. So this, we're going to measure this direction, we're going to measure this direction, and we're also going to determine whether or not it's within specifications or out of specifications. Our piston bore diameter on this particular engine is 70.5 millimeters. Okay, and there's a tolerance on that. If it's more than, I think on this one it's more than 5 or 10, we'll just say 10, is it 5/1000ths? Thanks, CJ looked it up for me. So if it's more than 5/1000ths of an inch, so in other words, if we have 71.0 millimeters, then what we're going to have to do is we're going to have to send that cylinder block into the machine shop, and they're going to bore it to an oversize, and then they're going to put a larger piston in it. And so that determines whether or not we have to have machine work done on the cylinder. And so anything over the 7.5, we need to worry about it, as long as, or if it's over 0.5 millimeters. So anything over 7.1.0 millimeters, we'll have to send it out to be machined. So hopefully this explains what we're actually going to be measuring on the engine. Okay, we're going to measure the cylinder bore here, and we're going to put this in, and on the back side of this tool there's a little spring that moves the needle back and forth like that pushes in, so that's got to be compressed. So we put the tool in like this, and what we're going to do is we're going to rock it back and forth to measure. And we're going to look at the lowest number here. So we zeroed it over there on the bench, and so if that needle goes past the 0, then that means that the diameter is bigger than the 70.5 millimeters that we have. And so if I rock this back and forth, if you look, it never goes past 0. So this cylinder at the top is good. So then we're going to move down about midway down through the cylinder, and we're going to do the same thing and make sure that it's the same, and it is. So it's still the same exact measurement. So now we're going to go all the way down here towards the bottom and measure it again. So this cylinder is okay as far as the taper goes. Now let's measure, we've measured this direction, so now we're going to measure in this direction here. And let me spin the dial around. Well, actually I can't do that without messing up the calibration, so we'll just move the camera around. How's that? That's easier than calibrating the tool again. So I'll move the camera over here so you can see. And we're going to measure back and forth like this. So you see it goes up to 0, but it doesn't go beyond 0. And so that measurement there is good. So we're going to go about halfway down again. And we're going to do the same thing. And it never goes past 0. We're going to go back down the rest of the way. And it never goes past 0. And we're going to do that on all 4 cylinders. So this cylinder here is in great shape. There's no out of round, there's no taper, and so this cylinder is good. So the only thing we really need to do before we reassemble this is to hone and deglaze it. And that will help the piston rings seat to the cylinder wall a little bit better.